unmute your microphone. Today, you will discover the HemoScreen. In the following 45 minutes, you will see how easy it is to work with the HemoScreen, and after the presentation, you have the possibility to ask questions or also write your questions into the chat. HemoScreen is the world's first true 5-part differential point-of-care hematology analyzer that can measure a fully hematogram by using just one single-used cartridge, without any sample preparation or additional reagents. But now it's time to introduce our speakers, and it's an honor for me to introduce you Yara Ben Youssef, Ariel Linker, and Jake Jones from PixCell Management. They know everything about HemoScreen. Please, it's now your stage. Many thanks that you are here and make it possible.
Thank you very much, Barbara. Welcome, everyone. I would like to thank you all for participating. And first of all, I would like to thank Axonlab for hosting this webinar, and especially to Sabrina and Barbara for inviting PixCell to present the HemoScreen. We appreciate very much this partnership with you along the year.
Thank you so much.
I will now share my screen. Let me know if you see it. Can you see the presentation now?
Perfectly.
Good. Okay, so let's start. I will move to the first slide. Jake, למה אני לא רואה את ה... ולא זזים sliding? Okay. Can you see the slide of evaluation of cytometry? Good. Thank you. So we will start with a short overview on the evolution of cell counting and cytometry. Starting from more than 100 years ago, people just did a blood smear when they wanted to see cells under the microscope. So they took a drop of blood and smeared it on a glass slide, and then inspected the stained cells under the microscope. Through the microscope, you can see the morphology of the cells with a very good resolution of the nucleus and cytoplasma. And you can identify even abnormal cells and small nuances between the different types of cells. And blood smear enable you to differentiate between subtypes of cells and populations. On the other hand, a major drawback of blood smear is that you cannot count the cells. And this is because the smear is dried on the glass slide, and you do not know the volume in which the cells are diluted in. So you cannot assess the concentrations of the cells, but only the ratios between the different subtypes of the cells. Also, blood smear review requires a lot of expertise from the lab technician, and it's very subjective, and it takes a lot of manual work to do. Then in the early 60s of the last century, flow cytometers were invented by, first of all, by Wallach Coulter. You probably know Beckman Coulter company. Flow cytometers are based on either electrical impedance and later on using laser scattering. Modern hematology analyzer flow cells in a line using hydrodynamic focusing, and then use a laser beam to enumerate the cells that flow under the laser beam. Through some signals that are collected from the flowing cells, you are able to differentiate subtypes of cells. And here in this, you can see a typical scatter plot. Each dot in the scatter plot represents a single cell. And you can see two populations of cells that are differentiated by the flow cytometers. Flow cytometers provides automation and very high throughput, but due to its low resolution, you only measure indirectly the cells and very few features of the cells. Therefore, about 50% of the blood samples that are run through the automated flow cytometers are sent to blood smear review because there are suspected cells that are identified by the flow cytometers. In the last decade, most of the modern labs are using digital microscopy like the CellaVision that some of you might know. The CellaVision performs semi-automatic inspection of blood smear, but still requires a lot of work by a qualified technician to confirm the classification. And also there is no cell count provided, only the ratios between cells. Digital imaging was enabled due to the development of advanced and high quality cameras and automation. What enabled PixCell technology to come in is a reduction of cost of these cameras and processors. And what PixCell actually did is to combine microscopic imaging and flow cytometry in one product called the HemoScreen. And I will explain about the revolution in technology on the next slides. Okay. So here you can see the HemoScreen on the picture. You see the analyzer on the right side. You see the disposable cartridge and the sampler. And sampler which is used to collect the blood sample. The HemoScreen is a small footprint cartridge-based point-of-care analyzer that in 3 simple steps provides a full CBC with 5-part differential count, as you see here in the bottom panel. You can use either venous or capillary whole blood, and without any pre-analytical steps or preparation, you just collect the blood into the cartridge and run a test, which takes 5 minutes. I will now stop the presentation and we'll just show you a live demo of how I collect the blood into the cartridge and how simple it is. So in just a second, I hope you can now see me. So I have here one disposable cartridge, one sampler, which contains 2 glass capillaries that are coated with K2 EDTA, which is a preferable anticoagulant. And I will use a standard high flow blade shaped lancet in order to prick the finger. And this is very easy. So I will clean my finger, dry it, prick the finger. I will not use the first drop of blood, we'll just discard it with a dry pad. We'll draw another drop of blood and collect it into the sampler. Okay. I will fill 1 capillary using a drop of blood and then use another drop of blood to fill the second capillary. Okay. Now that both capillaries are completely filled, and I will insert the capillaries and stick it into the cartridge. The sampler is now locked in. All reagents and the blood are sealed inside the cartridge. And last step will be to select on the analyzer to select test and insert the cartridge into the slot. Push it in, and actually this is it. You just have to either type manually or scan a barcode from a tube, and this is it. Okay. So I will move back to the presentation. Now we have 5 minutes. I will show you the results. I will print it out after the test is completed, and I will show you my results. And we will see if I'm healthy. So let's go back to the presentation. Okay. Okay. Sure. Okay. Now I will show you a movie.
PixCell Medical presents HemoScreen, a unique portable device equipped with pioneering technology that performs a complete blood count without a clinical laboratory. HemoScreen Reader provides immediate results within 5 minutes. Designed specifically to save time and operating costs. The test has a fast turnaround time and requires only a single drop of blood. The reader uses a disposable cartridge, ensuring ease of use and preventing any cross-contamination. No calibration or maintenance is required. HemoScreen is compact, lightweight, and can be used almost anywhere, making it extremely mobile and versatile. During the insertion of the cartridge, the blood sample is expelled from the capillaries into the reagent chambers. It is then mixed with the liquid reagents via actuators pressing on the pressable portions of the chambers. Once mixed, a seal bursts and the resulting suspension flows into a buffer chamber, and from there into a microfluidic chip. PixCell's revolutionary technology is based on a patented method called Viscoelastic Focusing. Viscoelastic Focusing causes cells to form a single cell layer, facilitating their optical analysis. The blood flows through a microchannel while cells focus at the center and form a single layer plane. Images of the focus cells are analyzed using cutting-edge machine vision algorithms. Cells are differentiated based on their morphologies and staining properties. Initially, the system counts the red blood cells, white blood cells, and platelets based on the cell's shape, size, and color. At a later stage, white blood cells undergo 5-part differential classification. Irregularities in cells' morphology are detected and can indicate various diseases. The analysis is rapid, accurate, and repeatable. The results can be saved, printed, and exported to a laboratory information system. HemoScreen is CE approved and scientifically validated. The only 5-part differential CBC analyzer FDA cleared for point-of-care use. HemoScreen by PixCell Medical. Lab-accurate results at the point of care. PixCell Medical presents Hemo. PixCell Medical presents
Yara, we can hear you.
Can you hear me now?
Yes.
That's great. Thank you. So as demonstrated in the video, the HemoScreen employs a breakthrough technology based on three main innovative concepts. One of them is the use of viscoelastic focusing. The second is imaging-based analysis and the AI. And the third is the use of a disposable cartridge. So let's go one by one. Viscoelastic focusing. Viscoelastic focusing of cells in general is an inherent requirement for cell count and cell analysis. Viscoelastic focusing is a new patent-protected physical phenomena. The cells flow and focus into a single layer, like you saw in the video, in a single layer plane with a microfluidic chamber in the cartridge, which facilitates their optical analysis. The cells migrate into the same position in the center of flow and are perfectly aligned in a monolayer, like we call it flowing blood smear. Okay, it's like you take a blood smear, but the cells flows in a monolayer. We focus the cell in a monolayer and not in a single file like in hydrodynamic focusing that is used in flow cytometers, cell by cell, single cell at a time. And viscoelastic focusing is much more robust, insensitive to movement or vibrations, and it also provides a very sharp focusing effect. It requires a very small volume of reagents, and the cells are in equilibrium of flow. The next aspect is the use of imaging-based analysis to classify the different types of cells. And as I mentioned before, laser scattering or electrical impedance are very limited in the amount of information they can draw from each and every cell. Images, on the opposite, contain a lot of information. The imaging allows us to monitor any type of interferences, and it is a very powerful tool, not only to detect what is happening within the cells, but also to detect some failures and other issues. And this is very important for a point-of-care device. And I will show you later some examples with respect to internal QC. The third innovative concept is the use of disposable cartridge. The HemoScreen cartridge is actually a miniature lab, like a small lab, that follows or mimic a complex protocol of sample preparation, mixing, staining, incubation, and different steps. It's all done automatically within the cartridge. And the cells, after mixing with the reagents, flows into a microchannel where the cells are focused and the reader counts the cells. So in user perspective, the cartridge-based solution is very simple, like an espresso machine, okay? The sample processing is done automatically, and there is no need for bulk reagents, no need for cleaning or maintenance, and no calibration is required, which is, of course, very, very important for point-of-care device. Okay. Jake, remind me that the test was completed. I will just print the result. And I hope you can see the results here. So all the 20 parameters. And you see that, I don't know if you can see, but I can tell you that all the 20 parameters are normal and my results are okay. So I'm healthy, I can continue. Thank you. So let's continue and move to the next slide.
Yara,
Yes.
sorry, can you show to the camera the cartridge
Yes.
after it was ejected,
Okay.
so people can see that the blood remains inside and...
Yes, and this is very important. Thank you, Ariel, for reminding me. This is the used cartridge. After it was used, you can see that the reagents compartment are mixed with the blood, and this is the measurement chamber. All reagents and the blood sealed within the cartridge, which is very important. No reagents or blood come in contact with the analyzer itself. Therefore, there is no need to clean, there are no clogging within the device, and no maintenance at all is required. And this is the concept of using disposable cartridge. And I will just discard it into a biological biohazard. Yeah. Okay. In the next slide, you see the HemoScreen cartridge. I will just move very quickly on that. So you saw the HemoScreen sampler just contains 2 blood capillaries with 2 blood samples. Each contains exactly 20 microliters. And one of them will be injected to the CBC reagents, which contains only viscoelastic focusing. It's responsible to measure the total CBC, total WBC, RBC indices, platelets, and MPV. The other blood sample is injected into these 2 stain reagents, which contains red and blue viscoelastic focusing solution, goes through an incubation period, and then creates the measurement of WBC differential parameters, 5-part differential parameters, and also can detect different morphological abnormal cells. Okay, with respect to performance of the HemoScreen. So PixCell has done many tests, evaluations, beta sites, studies, and submitted the data to FDA, to European CE, also to Australia. And you can see here many evaluation sites, many tests, and we demonstrated that the HemoScreen provides lab accurate results, and its performance is very, very similar to the high-end laboratory device. Most of the studies were done in compared to Sysmex-XN, which is the most advanced analyzer currently on the market. And here you can see accuracy results for selected parameters, HemoScreen versus Sysmex-XN. And of course, it represents, these are, for example, just the results that were submitted to the FDA in order to receive a 510K approval. So you see the correlation for RBC, hemoglobin, WBC, and platelets, and the results were demonstrated to be equivalent to the Sysmex XN in all parameters. You can see here approvals that we received in the recent years from the FDA for CE mark. Our notified body is DECRA, which is a very leading notified body. We also have a medical ISO 13485. Also, we have an approval from Korea health authorities and the Israeli authorities, Australia, and we sell in these countries. Ariel will speak about it later on. This slide just bring some results of the WBC differential parameters. The HemoScreen, and this is very important, is the only point of care CBC testing device with laboratory quality 5-part differential WBC test. And this is very important, and you see the correlation versus Sysmex, but it was also demonstrated against different type of laboratory devices, the Beckman-Coulter, the Yadvia, and many others, to demonstrate the very high accuracy. And also on the right panel, you see precision results, repeatability, to demonstrate the device is very repeatable and robust. Here you see a snapshot on flagging and interferences. Of course, if I have more time, so we can speak a lot about it, but just to show you some representative images that are created by the HemoScreen and how we can differentiate between the different subtypes of cells. So on the left panel, you see normal cells, red blood cells, white blood cells, and platelets. And in the lower panel, you see the 5-part differential, neutrophils, lymphocytes, monocytes, eosinophils, and basophils. And you can easily distinguish between the different type of cells based on the algorithms that are based on these images, now to identify like thousands of different features within the cells and to differentiate the cells based on their morphologies and staining properties. On the right panel, you see different interferences that are very common in hematology. For example, here on this lane, you see pictures of ghost cells. Ghost cells represent a situation which is, of course, not a good situation, where the blood goes through hemolysis, and this is very common pre-analytical failure or problem in hematology. So you can differentiate easily between these red blood cells are ghosts and between the normal red blood cells. And we can just create a flag or an error code if we, the HemoScreen encounter this interference. Another example is the presence of platelet clumps. This is also a very common interference that creates a falsely low platelet count. So you see here small clumps of several platelets, and the HemoScreen can identify and count the platelets within this clump and it is not confounded, as opposed to the flow cytometer that see sometimes confounded between clumps and lymphocytes, for example. The HemoScreen identify very accurately, based on the images of the cells, it can identify these interferences and flag for it. On the lower right panel, you see different types of immature cells, morphological abnormal cells. So you see here blasts, lymphoblasts, immature granulocytes, and NRBCs, nucleated RBCs. And you see the different morphology and the way that we can differentiate between these abnormal cells and normal cells. So it's just a snapshot to give you a taste of what the HemoScreen sees and how the algorithms process and learn to identify the even rare population of cells. Okay, this slide just describes the controls that are used in the HemoScreen. Okay, I mentioned before that imaging enable us to monitor and detect different failures or issues that might happen due to, for example, misuse, pre-analytical errors, or other source of malfunctioning, either device-related or cartridge failures. The HemoScreen, like other traditional hematology analyzer, has three-level liquid QC materials that are commercially available and manufactured by R&D systems in Minneapolis in the US. PixCell generally recommends to run liquid QC with accordance to the regulatory local requirements. But for the HemoScreen, the liquid controls only complement the internal controls, which is another very important arm of controls and monitoring. While the vast majority of failures can be detected by these internal controls, built-in controls, and before they can be evaluated by the liquid controls. So I will explain shortly about the mechanism. So the HemoScreen employs dozens of internal QCs that can monitor the complete analytical process and is thus able to verify the robustness of the instrument. This test performs every time you run a test. Most of them rely on the imaging to verify that everything is fine, everything okay. And if something goes wrong, the HemoScreen will present an error message and do not present erroneous results. And this is very important. You can see here an example of a report just generated by the HemoScreen instrument to report and to confirm that all internal tests pass. You have here some examples of different failures. For example, the device checked the vacuum system and the focus position of the cells. So there are dozens of cell tests that can comprehensive set of internal QC that eliminates the need to run liquid QC. And liquid QC, you all know, are very expensive, time-consuming, especially if you speak about point-of-care setting and use of disposable cartridge. So this is very important. And if you can use this reliable IQC system within the device, this is very helpful to eliminate the need to run QC. Okay, I think I get to my last slide. Just a snapshot on some scientific peer-reviewed papers that are related to the HemoScreen usability and clinical performance. The first two articles, and of course, after the presentation, we can send the entire list of publications, and there are quite many. But just to give you a taste, so the first two papers speaks about and recommend the HemoScreen for monitoring clozapine treatment in psychiatry patients. One group is from UK, the other group from University of North Carolina in the US. The third paper compare the HemoScreen versus the Sysmex-XN. This was a group from Finland, and they demonstrated the advantage of HemoScreen in clinical sensitivity and specificity to identify WBC abnormalities, and this is very important because this is what we always claim, that the HemoScreen can better identify, because it's mimic blood, what's happening in a blood smear. The HemoScreen can see the cells and identify very sensitively normal cells and also abnormal cells. So just a very short snapshot on that, and I will now stop my presentation and give you, Ariel, the Thank you very much.
Thank you very much, Yara. I'm sure that everyone enjoyed. One only thing to emphasize out of what Yara was explaining, and for you to understand that internal QC that she has spoken about is not something that the user needs to preset or look after. This is an automatic procedure that happens within the device every time that you run a test, which means that for us as the manufacturer, we know from that internal QC that the device works properly and that the results are completely accurate. In places where there is no regulatory requirement to run liquid controls in any given frequency, then using that, and if you need some sort of external corroboration, using an external quality program, an EQA program that you have in your country, for us as a manufacturer, is more than enough. But to understand that all these options are available. I'm going to show now my presentation. And no, I forgot to share the sound. Sorry, 1 second. Okay. Now, right. Okay, Barbara, I can only see you now, so can you just give me your thumbs up if you can see my screen sharing?
I can see your screen, yes.
Excellent. Thank you very much. So after the interesting presentation by Yara, I hope that I'm not going to bore you. I try to make it brief and to the point. So as Yara mentioned, beyond the FDA and CE certifications, HemoScreen holds regulatory registration in over 25 countries. For FDA, for instance, HemoScreen is, as she clearly said, is the only hematology analyzer 5-part diff cleared as a point-of-care applicable analyzer, meaning that there is no requirement for a certified lab technician to operate it. And it can therefore be used in doctor clinics, remote or satellite primary care settings, emergency centers, hospital in the home or home care services, field hospitals, pharmacies, actually in any location interested in reliable, immediate lab results without the challenge of repeatedly calling in patients, transporting blood samples, overcoming technician and lab load times, and more. Additionally, to that, and in addition to the venous blood sampling possibility, HemoScreen also holds an FDA certificate for direct capillary blood sampling, which opens a new mode of care for TRS patients, such as a pediatric population, psychiatric population, elderly populations, and more. Concerning CE, you need to understand HemoScreen is not only IVDD certified and CE marked, but it's in the final stages of becoming the first hematology analyzer to obtain full IVDR certification, and we expect that before the end of the year. Even though that this is going to be regulatory mandatory starting in 2027, meaning that from that moment on, in difference to analyzers that are CE marked based on a declaration of conformity by the manufacturer, HemoScreen is going to be the first analyzer that is fully IVDR and CE certified regulatory-wise. As I mentioned in the previous slide, PixCell is active today with HemoScreen deployments in over 25 countries with close to 1,800 devices deployed and a utilization rate of over 500,000 CBC annual tests. And we plan to double this utilization and deployment rate by end of 2025. We're experiencing an exponential growth with our deployments, both entering to new markets and expanding into new use cases and settings, placements in existing countries, and most importantly, increasing utilization with existing users. And beyond the certified utilization cases that provide indisputable corroboration to the device reliability and the ease of use and its accuracy, deployments also include research frameworks aiming at availing new models of care, such as home care for patients with acute medical conditions or populations for which there aren't other available solutions, such as neonates. And I'm going to speak about this later on, showing you some samples. Further to the HemoScreen commercial activities, PixCell is also active in the veterinary and the PRP segments via exclusive worldwide OEM agreements. The use cases we find mostly recurring for point of care through our deployments include a variety of settings in primary care, global, for instance, in primary care, global events like the pandemic, along with the workloads sensed by exhausted public healthcare systems and the ongoing competition between healthcare payers, continue driving service providers to keep patients away from crowded locations to avoid treatment to avail a treatment closer to the home, and shortening treatment times and repetitive visits to caregivers, with solutions requiring simplicity, zero maintenance time, and no additional resources. For oncology, the HemoScreen accuracy that was found in, as you saw, in numerous clinical studies to be superior even to that of major analyzers considered the golden standard in central labs, especially for white blood cells, platelets, and abnormal cells enumeration and classification. It makes it a superb solution to ease the challenge of chronic patients with any type of cancerous conditions or undergoing treatment requiring frequent CBC tests. And for pediatric settings, the certified capillary sample collection makes the patient experience considerably faster and more relaxed, ensuring a diagnosis can be promptly reached during the visit and without requiring additional visits and further longer processes for children and their parents, until they can obtain a full diagnosis. Beyond these use cases, the HemoScreen is constantly providing invaluable value in emergency settings, whether hospital emergency rooms, freestanding EDs, A&D centers, and others, availing both an immediate triaging to release unnecessary cases back to the community services, or to dramatically shorten patients' wait time to obtain a resolution. In ICUs and ORs or blood banks, whether there's a need to evaluate the profile of a blood sample or assess the required contents for a blood transfusion, or to provide access to immediate results without having to wait for the central hospital lab availability, in locations where central lab equipment is impractical due to sewage requirements, maintenance, calibration, and other requirements. So this is a massive use case where we see deployments of HemoScreen. Talking about psychiatry, that's another very fast-growing use case for HemoScreen, where the admission of clozapine requires a CBC and availability that includes an accurate ANC and absolute neutrophil count. And the abundance of patients with TRS calls for an alternative provision mode to increase patient engagement, both proven in numerous psychiatric settings that I will talk about in a few seconds. And above all these, nationally available care provision settings, HemoScreen is being massively deployed for CBC services to either expatriates, military service people through field hospitals, naval ships, or personnel or personnel of diplomatic missions in worldwide embassies, or tourists and sea personnel aboard cruise ships, or merchant marine, and more. To demonstrate some, real life settings, we love this picture in HemoScreen, but it's amazing. I am doing a lot of meetings with customers, and when you come to a user and you see this reaction, it really lifts your spirit knowing that you're doing something valuable. So, to demonstrate some real life settings, this is one of over a dozen NHS close-up-in clinics out of several dozens that we have worldwide, where HemoScreen became a game changer in adoption levels of a drug considered as the final treatment frontier. That's a tier 3 drug for psychiatry patients with mental disorders. In this case, one of the main factors allowing this change is the solution's portability, allowing to provide the treatment anywhere and by any team member without any required preparations. We take a huge pride in the fact that it takes only 45 seconds from taking the machine out of its transporting case, connecting it to power, to be running a patient test in the comfort of the patient location. Nonetheless, the game-changing advantages go beyond the clozapine adoption aspects. HemoScreen was found to deliver an incomparable improvement for inpatients, allowing their release from secure wards back to the community, thanks to its availing of an acceptable level of treatment in the community. This dramatic change in the treatment pathways further provide a radical decrease in costs to the secured facilities, both liberating beds in the facilities, a savings of £500 per night in this specific facility, for instance, and dramatically decreasing the required patient's transport to the hospital when they don't feel well, a procedure with a price tag of £3,000 per transportation. Consequently, in this facility that I'm showing in the pictures, the HemoScreen is used not only for clozapine patients, but also for the rest of the population because of the savings that it provides. The quote appearing here is by the head of psychiatry and the clinical director of this facility. He explained to me that 2 weeks before my visit, they had a patient very ill and unwell. The nurse decided to run a CBC test, and in light of the results, decided on her own to give the patient antibiotics. The doctor wasn't available then. The patient was finally transported to the hospital where they measured her clozapine levels that were shooting through the roof and could immediately provide the treatment that was effective only because of the provided antibiotics by the nurse in hand, deriving from the on-site CBC that the nurse could do. These pictures that you see here are only a few or a couple from more than 23 emergency settings in different countries where HemoScreen is used in a variety of modes. The picture you see below is from a major emergency room in mainland UK. It's a very big emergency ward with a huge parking lot in front of it. When arriving there, I saw an amazing spectacle of 14 ambulances standing in a half circle, all with the doors open towards the center. And when I looked inside, I saw patients either lying down or sitting on their stretchers. The paramedics couldn't bring them in because there was no room inside the ED. When I walked in, I saw more than 200 people sitting and standing, waiting to be served. I even felt bad taking the head nurse away from providing treatment. He told me that the main contribution from HemoScreen is the ability to perform an immediate CBC and send back home those that don't need to stay and can be further treated in the community without having to keep them there for hours in the hospital until the central lab can provide a service. Additionally, the simplicity of use ensures that the CBC can be made by any staff member, regardless of who is it on duty. For oncology treatment, as I previously mentioned, HemoScreen was repeatedly evaluated by several clinical and academic entities, performing differently oriented evaluations in benchmarks, comparing its accuracy to other solutions, both central lab, large-scale analyzers, those that are considered the gold standards, and other solutions that are so-called point-of-care solutions, as well as looking into the quality and accuracy for specific medical conditions treatment, such as pediatrics, psychiatry, pneumology, and oncology. For oncology treatment, as I mentioned before, HemoScreen consistently delivered a higher accuracy than golden standard lab solutions, especially with regards to leukocytes and abnormal cells counting. But in addition to the known treatment paths via hospitals and oncologist clinics, I mentioned before our participation in several research frameworks, pushing the treatment envelope even further. In this case, the picture that you can see on the top is from a very renowned professor in Finland, in Denmark, where the study began. In this case, HemoScreen was selected by the AMBER framework. The AMBER framework is an EU-founded initiative involving a number of prestigious cancer specialists from leading hospitals in Denmark, Germany, Poland, and Lithuania, that due to the expected increase of cancer cases in various South Baltic regions in the coming years as a result of demographic development, there is an expected rise of 24% in cases by 2035. They are interested in finding a more immediate model of care with the patient control in the center, allowing for patients at home to run their own CBC tests instead of dragging them back and forth to the hospitals to do that, especially when we're talking about providing a treatment or monitoring the change in the condition due to oncology treatment. The initial step covered breast cancer in Denmark, and it's now expanded to additional populations and hospitals in Poland and in Germany. Altogether, there are more than 35 hospitals, 35 settings where they have deployed the HemoScreen analyzers. As part of the last mile revolution in healthcare provision, bringing the caregiver closer to the patients, many countries face not only the challenges of staff shortages, but also inevitable characteristics such as a rural landscape with many distant communities and chronic patients for whom accessing adequate medical services and obviously lab services become a rare commodity where the services available can only offer hours of back and forth commuting, and with many chronic condition cases on a weekly basis. So I want you to see this short clip, and then I will say a few more words about it. Just Barbara, since I can only see you, give me a thumbs up when you can see and hear the clip.
Yes, you see the clip and hear it. Yes.
The PixCell is really aimed at those rural and regional facilities who may not have a 24-hour laboratory service or may not have any laboratory service at all. It just really adds to that clinical picture, allowing the local staff to make decisions about patients, whether that be to keep the patient at home, allowing them to be treated in their community, or whether it's safest for that person to go to a larger regional centre for treatment. One of the real advantages of the PixCell is that 6-minute turnaround time. Some of the facilities we're looking to install this device at are a really long way from their local laboratory. We're talking about 6-hour turnarounds with our current courier network. The samples that we're getting after those sorts of timeframes are just not ideal samples. We really want to have those tested earlier, at least in a screening capacity, to know which ones should be urgently sent and which ones should be escalated through the care network.
Okay, so just one thing to correct from what she said. It's not 6 minutes, it's actually 5 minutes, as you saw also from the test that Yara did. And you have an option if you don't need to run the 5-part diff and you just need the CBC count, then you can set it for 3 minutes only, and then in 3 minutes you can get the results. So this is New South Wales Health. It's the health system of the second largest state in Australia. They deployed up until now over 54 HemoScreen devices in 30 hospitals in different primary care health networks, availing lab services to districts that previously had no viable lab services, as you saw in the clip. And going even further than Australia, and again, you see those smiling faces. We cannot avoid from putting those pictures. These are pictures from HemoScreen deployments in Papua New Guinea, where several regional clinics have deployed the HemoScreen to enhance patient care in rural areas. The picture you see in the top is from the HemoScreen deployment in the most distant inhabited island of the planet, actually. It's called Pitcairn. It's a British territory in the southern Pacific Ocean with a population of only 47 permanent inhabitants that connect to the rest of the world via a single ship that arrives there once a month to bring supplies. So this is the connection they have to the world, but they have a HemoScreen device there, so they can run their CBC tests. When talking about mobility, the important considerations are not only applicable to the aspects of a small footprint or a low weight of the device, but mainly to the system's ability to be plug and play, not requiring any preparations and being able to operate with a power provision from any source, even a battery. The picture you see here is the mobile card-based solution developed by one of our distributors in Europe, allowing for hospitals and home care service providers a lab on wheels, where they locate their blood chemistry and blood gas analyzers alongside the HemoScreen, all powered from a UPS battery located on the bottom drawer of the card, allowing for bedside treatment in hospitals, emergency settings, confined locations such as prisons, and many others. In addition to the commonly known healthcare provision settings, there are, of course, additional settings requiring a constant monitoring of certain blood parameters to avert from deteriorating conditions. For instance, sport clubs, in this case, this club has had 2 events of athletes that passed away during training, one during a contest, which led to the decision of performing monthly CBC tests to the athletes as part of a complete set of health checkups in an attempt to recognize individuals with potentially hazardous conditions. As an additional example for point-of-care settings, many countries went beyond the availing of lab exams at the GP or specialist clinics into pharmacies, where in some countries it is possible today to obtain not only a telehealth session with the connected doctor to the pharmacy, but that can immediately dispense the prescription to the pharmacist for the required medicine, but now also availing a full blood lab test assay that includes a CBC. These pictures are from different pharmacies in several locations throughout Europe, where the pharmacist or one of the assistants are trained on capillary blood sampling and testing, providing the patients a full results within minutes, and through their connection to the healthcare system scheme, providing the results to the referring doctor for their follow-up in the community. And since I presume that you're tired from seeing more and more pictures, then the last slide from my side, a slide providing some pictures of additional deployments and settings, in this case, for instance, Italy, where we are including, amongst others, military hospitals that now are expanding into field locations because of the simplicity, because of the no need for any maintenance or sewage or reagents or anything, and it can be operated from a battery, then it can be used anywhere. District hospitals, ICU, and emergency departments in rural and mountainous regions where it is intended to avail a more convenient model of care for elderly populations through local medical centers in the vicinity of their houses and more. The most impacting one in this case corresponds to the largest pediatric hospital in Italy, one of the largest in Europe, where the leading clinician, one of the leading Italian hematologists, provides a home care service to children with acute oncology conditions using a department van that provides care and monitoring of CBC tests in the children's home, instead of having to drag them back and forth to the hospital for their condition. That's from my side. I hope you enjoyed it. I will stop my screen sharing now. And we'll be happy to hear your questions. Okay, I see that there are some people writing in the chat. So perhaps, Sabrina, you could read the questions in the chat.
Many thanks. The HemoScreen is an amazing analyzer. Thank you for your interesting presentation, and that you shared also in additional information like about FDA CLIA waiver and especially for us in Europe. We're absolutely happy that IVDR will be soon. That is fantastic. Now it's a possibility. Does anybody has any questions? You can ask now. You can unmute you. Yes, Nizam Ali, you have a question. Would you ask, please?
Yes. Can you show us the demographics again? The
Sorry, which
Demographic,
demographics?
where
The
to...
demographics, the age groups, male or female, the age groups. Can you show us that one more time? Or you enter?
We haven't shown any age groups. It is possible in the analyzer to set whether you are doing the test to a male or to a female, and then accordingly the thresholds of each parameter are modified. It is also possible to set an age limit. The device, in essence, is certified for use on babies from 2 months old and up without any limitations on the upper limit. But when you run a test on the analyzer, you can simply select on the screen whether it's a male or a female, and then the lower and higher thresholds are going to be modifying accordingly. And it is going to be shown, by the way, both on the screen and on the printout that you will get, and in the logs that remain in the device.
Yeah, you have one other question here is do you have a stylus for your screen?
Sorry, I couldn't hear if we have.
Do you have a stylus for the screen?
No, we don't provide the stylus for the screen.
Okay. What you have any that you could recommend for the screen?
It's a touch screen. You can, there is no problem to use it with with your finger.
Okay. One other question here. Is it possible that you can share some of your presentation with us?
Yes, if you register to the webinar, then you will be getting a link to the recording from Axonlab after the event.
Yes, because I did register, so.
Okay, so you will be getting a link.
Yeah. Okay.
There are additional questions.
Yes, many people are asking on the chat, so perhaps you would
yes,
like to read
you
them.
see it? Okay, then
I
you
see.
can see.
I see only a popping message, so perhaps you can read them out loud.
Okay, the device. Have the device been tested for transport for home visits, and how long is battery life?
Okay. First of all, yes, and we have today, I would say, above 100 to 150 cases where the device is being used in a mobile environment. This includes hospital vans, like I mentioned before, with Gaslini Hospital in Italy. This includes cases where you have home treatment teams that are going out to provide services for elderly populations in the community. This includes also ships, which are both cruises and military ships, where the device is connected to a power source. But to understand, the device needs connection to a power source. That can be a battery, an UPS battery, a car battery, or it can be the mains of the electrical network. But it does need a power source. There isn't an internal battery on the device, so there isn't any issue of how long can it work without connection. There has to be always a power source connected to the device.
Thank you. And the next question, what about the microcytic RBCs and large platelets? Is the HemoScreen, can he detect the microcytic RBC? Can he count them correctly instead of a other size? Oh, yeah, please.
This is a good question. I will take it. And yes, the answer is yes. The HemoScreen, thanks to the power of imaging, can detect the size, but also different other features within the cells. And this enable the HemoScreen to very accurately differentiate between, even if there are very small nuances between different types of cells. So even if there is a size overlap between large platelets, for example, and microcytic RBC, the HemoScreen, because it uses many features, dozens of features within each cell, so it can easily differentiate between these two types of cells and no confounded of cells, as opposed to the standard flow cytometers, which sometimes confounded between these very similar populations of cells.
That's great. That's a huge advantage for this device. Then I'm not sure. I'm sorry. What is the LOQ for granulocyte?
This is the limit of quantitation.
Thank you.
So the limit of quantitation and linear ranges were only measured for the total white blood cell count. This is the standard, and this is according to standard CLSI guidelines, which instruct which parameters should be measured. It's interesting because nowadays we get the approval to reduce the linear range for white blood cell and for platelets. So for white blood cells, it is currently 0.5 times 10 to the 3 per microliter, and it was reduced to 0.25. This is the lower linear range for WBC, and the limit of quantitation is less than that. Of course, it's, I don't remember exactly, but it's 0.15 or something like that, less than 0.25, which is now the allowable lower linear range for WBC.
I'm sorry if I add, that was my question, but specifically for granulocytes, because of in the use of clozapine or oncology patients?
Yeah, so that's right. So even if the granulocytes are 100% of the total WBC, which is usually not the case, but so it should be it's depend on the ratio of granulocytes out of the total WBC. I mean, if the current lower linear range for WBC is 0.25, so probably the granulocytes will be, the portion of granulocytes will be about 80% or even lower than that. So, but the total WBC is 0.25. This is the minimum, and granulocytes are, it's depend on their ratio from out of the total WBC. I hope this answers your question, but let me know if you need more information, please.
No, thank you.
Okay, there is a very interesting question about the noise. I think it's from PPA case Sugai. How about noise? Some things it is also detected at platelets. Can it detect as well? It's not the noise, the sound of the machine, it's the background noise of the counting. Can you say something about that, about background noise? In the common analyzer, there is still, when you have very tiny cells, then you have something like a background noise, but it's from software. What about HemoScreen?
Yes, so our AI algorithms can detect the size of a platelet, which is usually around 2 microns. So no problems for the HemoScreen to identify this size of cells. Particles smaller than 1 micron, it will be more challenging, but there is actually no need, because platelets are usually 2 microns and up. So, and we have no background noise if we test like a cell line or put no cells in the cartridge. So the readings will be 0. The results will be 0 also for platelets. So it's very sensitive and can identify platelets in different sizes.
Many thanks. Oh, again, a very interesting question about the stability of sample on the capillary. When it's once collected in the sampler, how long it is stable, the sample?
So according to the instructions, the general instruction says to immediately insert the sampler into the cartridge and then to insert the cartridge into the analyzer. But since the sampler capillaries are coated with K2 EDTA, so there is no risk of blood clots. Even if you take directly blood from the finger, once it's inserted and come in touch with the EDTA on the capillaries surface, so the blood won't be clotted. It can be kept out of the cartridge for, let's say, 1 minute or so. The instructions are to insert it immediately, but there is no rush, and you can wait a few seconds because there is anticoagulant in the capillaries.
I can just to emphasize that point that Yara just made. The case that I mentioned before with the hospital, the pediatric hospital in Italy, where the pediatric oncologist is doing a home tests. Something very interesting that he was telling me, that when they go to the children home, they have a problem because the parents are so anxious to see if there's an improvement in the children condition, that they are all the time standing behind their back to see the results. So they don't take the device out of the car, and they don't run the test in front of the parents. They take the sample, they put the sampler in the cartridge, they go out to the car is left running with someone inside, they take it to the device outside, and they run the test over there, and they find no problems with the time,
And next question is about the capabilities of HemoScreen to include the immature cells from the white blood. Is it planned that HemoScreen software will be extended to give more information what kind of immature granules?
Yeah.
Yes,
Immature
I
granules.
would like to
Cells. Sorry.
I would like to explain. HemoScreen today recognizes the abnormal cells, the immature granulocytes, the nucleated RBCs, the blasts, all the things that Yara mentioned before. But we don't provide a result attached to it. What we provide is a flag saying, we find this, we find the abnormal cells that require more, further investigation by your caregiver. We are, as part of the additional capabilities that we continue adding constantly to the device, we are now moving also into having those abnormal cells being provided not as flags, but provided also with their counting. I hope I answered the question.
Yes, I think the question was, can he count the correct number for immature granulocytes?
Yes, that's what I said. It can count, but we don't present the result.
It is the values are stored in the device in the log files, but we not yet displayed on the screen we intend to do it in the future. This is correct.
The neonatological, you told us about pediatricians. What about the neonatologic? Is it certificated from?
No, so I want to explain because this is a very important aspect. As I mentioned before, the device age certification regulatory wise is from 2 months old in the EU. There are many requests and many cases where there's an interest to use it for neonates because neonates is one of the cases where there aren't too many treatments available. So when it is done on a research basis by different hospitals or academia institutions. But it is very important even when it is done on a research basis, and we do see today very good results to understand how these are corroborated. Because the fact is that there isn't today an analyzer that is set to provide services for neonates. As you know, a baby is born, the bone marrow is not completely developed, and you get many irregular, abnormal cells that are created. So there isn't something that you can attach to. So what we are doing is that in those researches that are being done today, and there are many all throughout Europe done, even by NHS organizations in the UK, the reference is done via blood smears. So we have today, for instance, a setting with one of the largest trusts, NHS trusts in central UK, where they have a HemoScreen in the pediatrics emergency. They are interested to use it also in for neonates as a research. So what they are doing today is that on top of their use in a pediatric emergency, they are doing tests for neonates, and each test that they do on a neonate is also corroborated via a blood smear. So it's taken to the lab. They take the heel prick, they do a heel prick to the baby, they take a blood sample, they test it on the HemoScreen, and then they take it also to the lab, and they do an equivalent test via a blood smear, because there isn't any other analyzer that can provide you, a corroborated result. Any analyzer that they've been using up until now for that is used off-label, so no one says that what they provide is actually correct.
Okay, then we have more hematological questions about sickle cells, interferences like cryoglobulinemia and cold agglutinins. Very special cases, but sometimes
interesting. But
it gives a lot of headache with these patients.
There are, of course, countries and specific populations. For them, it is very relevant. So it's interesting with regards to sickle cell anemia. We just had a case in the US. They compared a sickle cell sample, and they got the results, and the MCV, they say that the MCV on the HemoScreen was much more accurate and what they expected to be relative to the results that generated by their Sysmex. And this is due to the fact that on the HemoScreen, in the viscoelastic focusing, we add a special material that causes cells to be circle, to look like a ball. It's a sphering agent, and this affects, of course, also the cells, the defective cells of the sickle cell anemia, and cause them to look like healthy red blood cells. And this is why the HemoScreen is not affected by these interferences. The same with regards to cold agglutination and cryoglobulinemia. I I'm sorry for not pronouncing it very accurately, but sometimes people think that viscoelastic focusing is affected by the viscosity or the thickness of the blood itself. If it's more or less sticky or concentrated, and this is wrong because the blood sample is diluted to a large extent when inserted into the reagents. So there is no effect of blood thickness on the HemoScreen test or results. This has no effect.
Do you have experience when patients have problems with cryoglobulins and cold agglutinins?
Yeah, so as I mentioned, this will not affect on the test results. Sometimes I can recall one case in which the test failed for cold agglutinins on, I think it was, it reports hemolysis, and this is because probably some of the red blood cells were destroyed or lysed, and the HemoScreen detected. And sometimes it didn't fail, but just created the accurate results, and this is okay.
Great.
Which is, by the way, an important thing to mention, Yara, regarding the fact of how do we count. We actually count, and don't do a lysis in order to provide results on hematocrits and the.
Do you also have the parameter, the indices, so the hematocrit, the MCV you mentioned, and MCHC as well? And
yes.
MC
Yes. Who is asking, by the way?
I just briefly mentioned it. So we count the RBC. There are all sort of RBC indices, MCV, hematocrit, MCH, MCHC, RDW. What else? I think I haven't forgot anything. Hemoglobin, of course.
RDHD, hemoglobin, hematocrit.
Some of them are calculated, some of them are directly measured. If you need any additional information, I would love to provide it.
Thank you. And now also technical question. Is there an official overview about LIS, so and point of care middleware systems?
There is a full
connect?
list. There is a full list. We cooperate today with more than a dozen different solutions, whether we're talking about LIS systems as a whole, or whether we're talking about middleware platforms, whether we're talking about commercially available solutions, platforms that were developed as such, or whether we're talking about systems that were developed like the Axonita from Axonlab. So there are limitations. It's a very straightforward driver that enables connectivity both via HL7 and POCT1A protocols. And whoever is interested to buy a lot of HemoScreen devices, I will be happy to provide you a full list of the supported lists.
Many thanks, Ariel. So at the moment, I cannot see more questions. We had a very long webinar. Thank you for your time. It's so interesting. I think we could speak until in the evening, but it's interesting. But I think the time is now to say again, many thanks all of you, and also my colleague Sabrina Lessig. She managed all the marketing work. I hope you enjoyed the presentation. And now, if you would like to have a device demo, don't hesitate and contact us. We would
We
be
would
happy
like
to
to
support
thank you
you.
also, Barbara and Sabrina, first and foremost, and everyone that took the time to join, to register, to listen in. And we will be happy to be at your disposal for any additional information required. And again, Barbara, thank you, and thank everyone at Axonlab for this opportunity.
It was so great to meet you. Many, many thanks.
Thank you, everyone.
Thank
Thanks.
you.
Bye-bye.
Have a nice afternoon.
Thank you.
See you soon.
Bye-bye.
Bye.
Bye-bye.